Okay, welcome everybody. This is Will Frazier and Wesley Cole. We're doing a, we'll call it a training, an introduction, something there, a tutorial on how to add inputs into the Augur submodule of ReEDS. So Augur is a portion of ReEDS. It's named after these augurs from ancient Rome that would look at, use birds to interpret signs of what's coming. And since we're using, in ReEDS, we're looking at what's coming in the future. We're looking to see the value of technologies out into the future. We've called it Augur with the submodules named after birds. So go to the next slide here, Will. So Augur is doing an 8760 dispatch inside of the ReEDS model. So it's doing it for all the regions every hour of the year. Generates energy prices, generation, transmission, storage, dispatch, and we're using all that information to calculate curtailment for variable renewable energy technologies, primarily wind and solar, the diurnal storage value and its operation, and system reliability metrics, primarily capacity credit metrics. So all this hourly information is used to get these parameters that are then fed back into ReEDS that solves the full investment and dispatch problem for the next solve year. So at times you're going to need to add new inputs to this as you're doing development. So Will, who developed most of the Augur code, is going to walk through how you could do that. So Will, go ahead and take it away here.
So this is the main ReEDS folder here. So you'll find an Augur file here, which is the main driving script for Augur, and then there's also a ReEDS Augur folder, which includes a few scripts that run along the way, and a utility folder as well that includes, a few extra files that are performing some of the characteristics deeper in the weeds. So Augur draws its inputs from several different places. So first, there are inputs that it draws from this value defaults file here in the ReEDS Augur folder. And this is just, rather than hard coding a few things, we have several default values selected here in this value column that can be changed if needed, but generally I wouldn't expect anybody to need to change these too much. These are meant to be just static values that could be changed should they need to be in certain cases. One interesting one here is this remove CSV. So there are lots of intermediate data that gets written out in Augur that is deleted after each time Augur finishes. If you don't want those to be deleted, if you want those to hang around so that you can look at it and see what's going on, you would set this to false and it would no longer delete those files along the way. Another place it's going to get some information from is in the inputs folder. There's a variability folder in here, and this includes several CSV files that get read into Augur. This is also where the hourly profiles live. So the hourly resource and load profiles live inside this inputs variability folder in ReEDS. Another place it's going to get information from is the cases file itself. So when you run ReEDS, you have many options for all of these switches that are included in the model, and all of these switches make their way into Augur with the value assigned to them for whatever scenario you're running. Another place it's going to get data from is when you're doing a run. Let's see. When you inside your run folder is going to be this ReEDS Augur folder as well, and inside that there's an Augur data folder. And when you're doing a run of ReEDS, it's going to write out this ReEDS data file after every solve year, And this includes dynamic information from ReEDS about investments and other things related to the optimization in ReEDS that need to be included in Augur to inform the 8760 dispatch and the other calculations that are happening in Augur. So there is some information included in these. And then the last place where it's going to get information from is from Augur itself. So Osprey is also a GAMS optimization file, and Osprey is the actual 8760 dispatch optimization. So when this runs, it finishes and it writes out a set of CSV files with the year included of what year was solved. And so those are read into Augur as well to perform the calculations. So there are many places where information is being read in from into Augur to do all of this. So what we're going to look at today is how you would want to add something new to Augur if you wanted to. So first we're going to talk about the static inputs that Augur has. So when Augur is called by ReEDS, it receives 3 arguments. It receives the next year that's going to be solved in ReEDS. It receives the previous year that was solved, and also the name of the scenario. And the first thing it does is it calls this set switches function. So as I mentioned, in our ReEDS Augur folder, we have this utility folder that's handling some stuff deeper in the weeds, and this switch settings file is what's handling all of these static inputs and switches that come into Augur. So it's going to grab all of the switches from the cases file, and it's going to grab everything from this value defaults file. And it's also going to use the command line arguments to set everything there. So here I have Augur pulled up for a certain run. And I've already run a couple of things here, so all of my switch settings are already set. So there's a class, or sorry. So for this class, switch settings is the parent class for every class inside of Augur, and it has an attribute called switches. And this switches attribute is a dictionary, and every switch is going to appear in this dictionary with the name of the switch as the key and the value of the switch, the value in the dictionary as the value of the switch. So if I go here and I look at switch settings switches, it's just going to show me this big dictionary we have of all of our switches and default values. So at any point in the code, if I want to access any of these, for example, let's see, we want to access our, so this G switch storage, this defines whether storage is on or not in the model. If this switch is set to 0, then there's no storage in the model. Maybe there's some piece of Augur that I want to not run if that's off, so I would make sure to add if settings switches and the key G switch, right? I can check and see if that is equal to 0 or if it's equal to 1, and I can use that as a conditional somewhere in Augur to have some code run or not run if that certain switch is on. So let's say we wanted to add a switch, and the example we're going to use today is we want to add a hurdle rate to transmission lines in Osprey. So we're going to use, first we're going to just assume this is going to be a static hurdle rate. The easiest way to get that into Augur would be to add it to your cases file. And you could add another switch at the bottom here and call it hurdle rate. Right, and this will be your transmission hurdle rate. And we're going to set it to 10, and we're going to make sure we have our units in here. It's megawatt. So then this information would get passed into Augur, and we would have a hurdle rate, and it would be set to 10. So I'm just going to set that manually here since we don't it's defined previously, but it would be defined were it to have been in the cases file earlier on. Oops. Okay, so then we would know that we would have this hurdle rate in here, and the way Augur functions is once the switch settings is defined, then it calls this prep data function. And
so we'll just quick
yeah,
question
sure.
here. So this, you add a new switch, you don't have to change anything in the code for the switch.
You don't have to change anything.
Set up to just, so you could add as many switches as you want, and it'll just take them all in.
It'll take them all in, yeah. But if you want them to do anything, then you have to add them.
But you got to add code to operate on it, yeah. But,
right.
but just in terms of getting them in, there's nothing except
no extra work needed to get them into Augur, other than just adding them either to the cases file, or you can also go in here and add it to the value defaults file. The distinction we make there is generally things that we expect to stay static always, we put in this value defaults file, and things that we expect people may want to tweak or change the value of, then they generally go into the cases file. So if I wanted to act on this and I wanted to add this hurdle rate, the first, before we run Osprey, so Osprey is our 8760 dispatch, but we prepare all of our data before that, and that's in this prep data function, which we are importing from our ReEDS Augur folder. So in ReEDS Augur, we have this aprep data file, right? And I have this pulled up over here, or actually I don't. Here it is. So prep data is going to, format profiles and get the generator capacity of all the different technologies from ReEDS and apply some calculations on your different technologies and the capacity and what properties those different technologies have, and make sure all of that gets packaged nicely and sent to Osprey. We have just a few more things here involving profiles, and we've added a hydrogen production capability to ReEDS, and so that's included here. So what I would also do here is I would probably just come to the bottom here and say my hurdle rate would be equal to settings dot switches hurdle rate. And then this is going to be read in as a scalar. So I think if we wanted to write this out to Osprey, we'd probably want to make it into a data frame or something. I'm not going to concern with the logistics of that right now. You would want to make sure it makes it into this Osprey inputs dictionary here, and so each key is the name of the parameter that's going to get into Osprey, and then the value here is the data frames for each of those. So we can go in here to our ReEDS Augur data, and that this Osprey inputs file is what we're talking about here. So as you can see, we have cap prod, cap converter, transloss, all of these different properties, make it into this GDX file that's going to get read into Osprey and used.
So will the reason you're concerned about the scalar going in there is that everything has to be a data frame?
I don't know if it does or not.
I
think you can send something in as a scalar in GAMS. I'm less familiar with GAMS, and so I'm not sure exactly.
Okay.
So
the scalar doesn't work, convert it to a data frame, and then it should work.
If it doesn't, yeah, sure.
Okay.
And then once you have your hurdle rate in here, then you could open up Osprey itself and add the cost of transmission to your objective function in here. So the hurdle rate times the transmission would just be added to the objective function inside of Osprey. So static changes in Augur are pretty easy. Let's say we wanted to ingest a new input from ReEDS that's actually depends on the optimization of ReEDS. Like it may change based on how ReEDS operates. So the way that ReEDS functions is once the model is set up with the inputs, and then we have the model itself and the objective function in these two files. This D process is actually what's solving the model. So depending if you're solving intertemporal 1 year at a time or a window, you're going to roll through a loop here. If you're doing a sequential solve where you're going to solve 1 year, you're going to go to this var fix piece and then this D3 Augur data dump file, which is going to dump out all of the information from that year's optimization so that investment decisions and other things that depend on the ReEDS optimization can make it into Augur and inform Osprey and the other calculations that are happening in Augur. And when that's finished, it's going to write out a GDX file that's going to be read in by dsolve prep, which will then update the parameters for ReEDS and then go back to dsolve 1 year. This loop will continue until.
Yeah, the dsolve prep is actually read at the beginning, so it's in the dsolve.
Oh, dsolve prep is at the very beginning. Okay, so it's going to go back to dsolve 1 year where these are redefined, and then it's going to call the model and run the model again. Okay.
So summary is that data from ReEDS to Augur happens in D3 Augur data dump.
Yes.
That writes out a GDX file that will then go to Augur. And then once Augur is done, it writes out a GDX file that goes back to ReEDS, and that's read in the dsolve 1 year, dsolve window, dsolve all years.
Yeah, on and all of this in your run folder, all of this is going to be in the ReEDS Augur folder, Augur data. You're going to have ReEDS data that's coming from ReEDS into Augur, and then you have this ReEDS Augur file that's coming from Augur and going back to ReEDS. And then you also have your Osprey inputs, which is inside of Augur. Augur is formatting data and writing that to Osprey. And when Osprey finishes, it writes out this Osprey outputs file, which is then used by Augur and deleted at the end of once Augur's finished. This file is deleted unless you tell the model not to delete those if you want to look at the intermediate data along the way in Augur if you're suspecting something is wrong. Okay, so D3 Augur data dump. So this file runs after every solve year in ReEDS, and we're going to write out this ReEDS data GDX file for Augur. Any parameter that's actually used in the model you want to include here. For example, our capacities have to do with the investments from the model. So we have our capacity has to do with the investments, the investment referb. A lot of this is structured very similar to the e-report file. If you're not familiar with ReEDS, this e-report file writes out the the final solution for ReEDS, as well as all intermediate years along the way. So if there's something that's being written as an output from ReEDS that you want to add into Augur, then you can use the code from eReport as an example of what you would want to put here into D3 Augur data dump, so that gets written out every year intermediately, so that it can be used to inform Augur. And then all of these are written out at the end here to this ReEDS data next year GDX file. All of these parameters here, allowed shed is a new one that must be a demand response thing Brady just added. So these are all read into Augur in a very specific way. So we use a specific method for handling all of the data coming into Augur, such that everything in Augur is synced together, because there are different changes you can make in ReEDS. For example, you could be using the water cooling capability that ReEDS has, or some of the climate capabilities. They changes the technologies a little bit, and some of the other data structure in ReEDS, and so to make sure all of that is reflected properly in Augur automatically, we use in our ReEDS Augur folder, in the utility folder, there's this inputs Python file, and this inputs Python file is the file where all of the data that's going into Augur flows through. The switches and static settings flow into Augur through the switch settings, but everything that's can be dynamic or is part of a CSV or something like that is read in through this inputs file. So in inputs, we have a few classes defined. This parent class here, the Augur input class, has this get data method. And this is the meat of that file, and this is just going to make sure that we don't have any uppercase versus lowercase issues, because Python is case sensitive, whereas GAMS is not. So we want to make sure that we don't have any bugs that arise based on case sensitivity. There's a couple switches here for if you're using the upgrades capability in ReEDS or the water switch capability in ReEDS, making sure your technologies are named correctly, and properties of a certain technology are also assigned to the technology upgrades that are associated with the same technology. Just ignore that if you're not familiar with the upgrades capability in ReEDS. It's not too big of a deal. Making sure that we don't have any regions that aren't actually included in the model you're trying to solve. So if you're solving ERCOT, we're going to filter everything besides data that's pertinent to ERCOT in this step. This just makes sure everything is standardized once it's in Augur. But these data could be coming from many different places. So we have the pickle files, which comprise all of the hourly data, the hourly profile and load data that goes into Augur. We have CSV files that get read in to Augur, and then we also have the GDX file that reads data, GDX file that's written by D3 Augur data dump. There's a special one here for technology mapping that I think we might get into at the end of this a little bit if there's time. So all of these parameters that are used in Augur are part of this inputs dictionary here. And once again, the key is going to be the name of the parameter, and then the value is going to be an instance of one of these classes up here. Any property that's coming from the GDX file is going to be an instance of the GDX input class. Anything that's coming from a CSV is going to be an instance of the CSV input class. And if we go back up here to our CSV input class, we'll see that when we initialize this, there are two arguments that are required. We need the name of the file as well as the name of the columns, because these are all assumed to be data frames. The data frame is set to none, and then when the data is read in, if the data is none, then we'll read in the data. So this keeps us from reading in the same data many times if it is read in. So we can see here.
So Will, does this suppose that like your CSV files have column headers? Or do they need column headers as long as you specify it in here?
They need column headers. We could, it wouldn't be too difficult to add an extra argument here that we could even do a keyword argument like headers equals true,
yeah.
right? And then if you had,
right now it supposes you have a header and that the header matches the name that you give it in the.
Well, no, it doesn't assume the headers match the name. It's gonna.
As long as, okay, so the order your order needs to match.
Yes, the column.
Okay.
Yeah.
But the,
and that
the names
that
need
can
not
be
match.
modified, but at this point, that's the assumption that's made.
Okay. Okay. Cool.
So this can trade 8760 is coming from inputs case can trade 8760, which I would assume is going to be in our inputs variability. Oops.
No, we have a Canada folder at the very top.
Oh, there's a Canada folder.
Yep.
Inputs, Canada inputs. Here's our can trade 8760. Cool. So this makes it from here into the run folder, the inputs case folder, and from there it's access, and the column order is R hours T megawatt. If you don't specify the column names here, it'll use the column names that are included. I tend to specify the column names, especially because when G3 Augur data dump executes, they tend to not have, well, they do have the column names here. At any rate, this just helps make sure that your column names, if you're doing any operations inside Augur that are specific to the column names, that everything is consistent there. Another piece that we have here is this CSV input with switch. So this is going to read in a CSV file that has a switch at the end of it. So if there's, these are all coming from Osprey. So when Osprey solves in 2030, it's going to say storage in 2030. And so this is just making sure that we grab the right CSV file from Osprey if they're not being deleted. So if you have storage in 2020, 2022, 2024 from every year and they're not being deleted, then we're making sure we're reading in the right file here. So all of that being said, if I wanted to add a new input, so if there were a parameter in ReEDS that I wanted to include that's not included in this list of parameters that are going to Augur, then I would add a new parameter here, make sure I define it properly relative to what's happening in ReEDS, and then I would add that property down here. So let's just choose something here that is not in there yet. So one example is this rep gas quant. So this is the quantity of natural gas that's being consumed by census division and year in ReEDS. And right now this is being used to determine the marginal gas price, the marginal natural gas price in ReEDS. But let's say for whatever reason we wanted to also send the total natural gas consumption to Augur, then I would come down here and I would add rep gas quant to our to our GDX file that's going to Augur, and once rep gas quant is added here, then I can come to our inputs file.
So hold on a second, Will. So one thing that's different though is, at least looking at all the D3 Augur data dump, it's not defined by T. Like all your inputs are not defined.
Oh, that's right. Okay.
So you does that need to be the case? Is it okay to send something with a T index?
It would be okay. It's yeah. So that's a good point. We do filter on the year here to keep from sending duplicate data. Although looks like the rep gas price is indexed on T, but it's.
Well, then you go down the rep gas price filter where you.
Oh, right. Okay. Yeah, I've added these filth ones that filter out for only the year we're looking for. So yeah, we probably.
You don't have to worry about. You don't have to filter out, but you could if you wanted to.
You don't have to, but it's just going to make that GDX file that is written out it's going to make that ReEDS data GDX file bigger than it needs to be. So it would be good form to add rep gas quant filth, and this is just going to be by sendiv, right? And then it'll be the same thing. The T cur T. Also, T cur and T next are defined at the top of this script. T cur is the year that was just solved, and T next is going to be the next year that will be solved. So if you are sending stuff to Augur, make sure that you think a little bit about whether you want to send the next year or the current year. Obviously, if you're sending anything that was relevant to the optimization, such as the natural gas price consumption, you're going to have to send T-cur because T-next doesn't exist yet. It won't exist until you solve the next year. But yeah, it would be good form to do rep gas quant. Filt rep gas quant sendiv T. Not necessary, but good form. And don't forget, you would also have to add that up here. We would want to define the rep gas or rep gas quant filt. And this will be added here. Thanks for stopping me on that. I forgot about that. Our rep gas quant filt would go here, and then we would come to inputs, and then let's see. Some of these have different. I sometimes disagree with Max on what a nice name will be for a thing. So rep gas price filt comes into Augur as NG price, and if we wanted to do NG consumption, which is what I would go for the name of this. We would say it's a GDX input because it's going to come in that same file. The name of the parameter is going to be rep gas quant, and it's going to be indexed by sendiv, and then this is going to be, we would probably want to use the units here. What are the units for natural gas? I think it's like,
yeah, here. I don't know, you'd have to go check it.
It probably says in the report. Let's just say gigajoules.
I know it's not that, but that's okay.
Not gigajoules. So now we would have access to this NG consumption. So just to show an example here, let's look at inputs. NG price get. That's going to grab our NG price data. So we have by region, we have the fuel price, and since we just added it, it's not included here, but we would access the NG consumption the same way if we needed to use it somewhere. So if we wanted to modify, let's come back here to this aprep data. If we wanted to modify any of these by, let's see, the natural gas consumption, or if we wanted to send the natural gas consumption to Osprey, we would access it the same way. We have this inputs dictionary that we are importing at the top here from reedsauger.utility.inputs, import inputs. Anything that's in all caps is a dictionary, and these are generally dictionaries where each key in the dictionary, the value is associated with an instance of a class in one of these files in the utility folder. So yeah, we would access it here the same way. Inputs ng consumption.get data. So that is how you would add a dynamic property from ReEDS. The last thing we wanted to cover here is how you would add a new technology to Augur. So we're going to cover a couple of things here. Going back to our ReEDS Augur folder, inside the utility folder, as I mentioned, there's this generated data file, and this generator data file is going to handle all of the data manipulations that are specific by technology for each of the generation types. So our generator data file has a hierarchical class structure, the parent class for everything, which is a subclass of switch settings, meaning that any instance of the class tick data also has access to all of the switches in switch settings. So let's get that dots. So the number of decimals that we round to, for example, is set in the switch settings, and so all of the instances here can also, through themselves, access this switches dictionary and be able to tell how many decimals to round off to, and also filter for the year or whatever other switches is needed there. So these are all of the properties for generators that are used in Augur or Osprey. So we have our available capacity, daily energy budget is related to hydro, and also hybrid PV battery resources. Defines a daily energy budget for these resources to use in Osprey, because Osprey solves in 24-hour windows and then stitches all the results together. So when we have properties such as hydro availability that vary by season, we allocate the resources for each season across every day equally, or we could choose different ways to handle that. But if you wanted to change that, you would have to go down to the hydro class and then modify how its set daily energy budget method is operating. Energy capacity, the cost of generators, these have to do with our hourly profiles, max capacity, min-gen, and then this ret frac gets passed back to ReEDS. It's not actually used in Augur. At any rate, if we scroll to the very bottom of this file, we're going to see this, first of all, gen data dictionary, which includes all of those properties for each generator, and then gen text. And gen text is where we define each of our technologies. And once again, so we have this dictionary here. Each key is a technology category. And each value is an instance of a class where we're going to have specific ways to handle some of the properties that are included here in this gen data class. So let's look for coal is defined as a tech data, which if we scroll back to the top, that was our original parent class here. Tech data. So tech data has some certain methods here defined on how it's going to set some of these, each of these parameters. So for example, we have format available capacity, which actually uses the max cap, so that's not the easiest example to start with. Let's say, so we have format daily energy budget here, and then since daily energy budget, most technologies don't use this, so we're just going to return none for any technology that's defined as a tech data technology. Formatting the gen costs, you're going to get the fuel costs for that technology, the VO&M cost, and then filter for the tech that we're using and add those together. So the point here is that all of this is defined for tech data so that we have a base level representation for generators in Osprey and Augur. But as I mentioned, there are some technologies that have different manipulations that are specific to that technology, such as biopower, for example, where it shares everything with tech data except for its fuel cost is coming from a different place than most of the fuel cost, because the fuel price for biopower is coming from this fuel price biopower parameter that's specific to biopower, since we also determine the price of biopower endogenously in ReEDS based on the consumption. So if I scroll down here to the bottom here, we'll see that biopower is this set to this biopower data class. So it's going to use everything from tech data except for the things that are defined here in biopower data. So we're going to inherit all of the properties from the parent class, and we're just going to redefine a couple of these here, which makes all this a little easier to deal with. So generally, if you add a technology in ReEDS, it's probably going to be part of one of these categories. And the categories are defined here by this, this key. So the argument sent here to any of these, let's scroll back to the top. When we initialize an instance of the tech data class, the only argument that's required is this tech key. And this technology key is going to be associated with the I subset from ReEDS. So if I open up, I close these so that this is a little less confusing. So I want to grab this ReEDS data file from the ReEDS Augur folder. So Augur data, ReEDS data. And there's this I subsets. Is this a parameter in ReEDS? I think it is a parameter in ReEDS. So for each technology I in ReEDS, there are lots of like I subtext defined so that we can apply certain things in ReEDS that we want to apply across a whole set of technologies. For example, we have this RE set of technologies, and for handling recs and other things in ReEDS, it's useful to have this RE class. And these tend to have a hierarchical structure where, for example, all of our coal technologies in ReEDS are all under this coal subset. They're also in this conventional subset, which also includes natural gas and nuclear. But for the purpose of Augur and Osprey, we down select to just this coal type. And so this allows us to grab all of these coal technologies without having to worry about typing in each of the individual coal technologies somewhere. So if I go back to my generator data file, we'll see that coal is an instance of tech data and the key we gave it is coal. So it will grab all of these coal technologies in one fell swoop. So if we add another coal technology, let's say we add a coal CCS, as long as that coal CCS technology is part of this same coal set, then it's going to be incorporated into Augur automatically. So these keys over here is what you're going to want to pay attention to if a technology does get added to ReEDS. Geothermal is the same way. It's also, there's nothing special as far as Augur and Osprey are concerned with geothermal. So it's another instance of tech data, but its tech key is going to be geo. So when it filters on the technology, it's going to grab all of our geothermal technologies, which I believe are extensive, if I remember correctly. Yeah, there's tons of these different geothermal technologies that are all going to get grabbed in geo in one fell swoop. Generally, if you add a technology, as long as it's included in one of these same technology sets, then it's going to be included in Augur automatically. One thing to be careful of is if it's in, like, if there is some sort of technology that's included in both, like if we had a technology that was included in the PVB set and also in the UPV set, then it's going to be included twice. So we want to make sure that there's these technology keys that define each of these technology sets. We don't want there to be any overlap between any of them. So let's say I wanted to add a new technology. Let's say I wanted to add a wind battery technology. Let's see, we'll just start by calling it tech data. If there were a wind battery set in this iSubtech that included all of our, wind battery technologies. So actually, if we search for PVB here, because we do have PVB right now in ReEDS, and it includes all of these technologies in the I set, which define the duration of the battery and the quality of the PV resource. If we had a similar set of technologies for wind and there was a WB subtech, then we could include that here. And let's say that wind battery is effectively the same as PV battery. There's no difference between the two. Well, we already have a class defined for PVB data, so then we could probably just assign that same class here, and then now we would be done at this point. Wind battery would be included in Augur, and it would have all of the same properties as PVB data. If we would probably want to rename PVB data to be hybrid data. If that were the case, we would rename every instance of that. This class would now be hybrid data, and then these would be set to hybrid data, so that's there's less confusion between defining wind battery to being a PVB data class. Or maybe there are differences between the two, but they're just a couple of subtle differences, in which case we would probably want to rename this to be hybrid data. And we could have a couple of subclasses defined that are specific to PVB and wind, and we would still have our class PVB data, class of hybrid data, and then we could define our class battery data, the subclass. we could just have whatever small differences between the two defined here, and they would all inherit the same properties that are generally assigned to all hybrid resources. And then I would come down here and make sure that wind battery data and other PV battery data here. So adding a technology to Augur should be rather simple. You just have to make sure you understand what properties are being assigned to each based on the hierarchical structure of this class system, and make sure that your key is defined correctly relative to the I subset parameter in ReEDS. And I think this is actually coming from a text subset CSV file, which you probably don't need to get into right here. But that would be how you would include a new technology. So we've talked about adding a static parameter, whether that be a switch or a default value. We've talked about adding a new parameter from ReEDS based on the ReEDS investment and how we get that into Augur using the inputs.py file. And then we've also talked about how to add a completely new technology to Augur, were there to be a new technology added in ReEDS, and when we actually need to make that change in Augur and when it's going to happen automatically. So cool. Tons of information. Wesley retained all of it, so if you have any questions, make sure you reach out to him.
I'm ready. I'm ready to be an Augur developer now. I'm set. Cool. Well, thanks, Will, and I hope everybody enjoys the video. Feel free to follow up with us if you have questions about anything you've seen here or thoughts on piece of the model. Always happy to hear from you. So thanks, everybody.
Thanks.